So we are looking at 8.1. We're learning about Pythagorean theorem today, which we've done before in here, and I know you guys have done before as well. So hopefully this will be a pretty easy lesson. Chapter 8 is all about right triangles, and so that's why we're starting with Pythagorean theorem. And the Pythagorean theorem states in a right, only a right triangle, not an obtuse, not an acute, not a left, a right triangle. The sum of the square of each leg equals the square of the hypotenuse. So what that means is a squared plus b squared equals c squared. I think that's it. Let me make sure I didn't say anything special last year. Nope. Okay, perfect. So the sum of the squares of each leg is my a squared plus b squared. The square of the hypotenuse is my c squared. So c is always my hypotenuse. So make sure it's the long side across from the right angle. That's always by itself. All right, so let's do an example. We're going to solve for x. Does x in the next example go for a, b, or c? C, very good. It goes by itself. That's my c. So I'm going to do 9 squared plus 12 squared equals x squared. 9 squared is 81. 12 squared is 141 equals x squared. 81 plus 141, or 144, excuse me, is going to be 225. And then I get to square root both sides. Square root of 125 or 225 is 15. Ooh, 225 is 15. All right, questions so far? Questions, concerns? Everybody with me? Okay. All right, now we keep going. We got another one where we got to solve for x. This one says express your answer as a simplified radical. It means if you give me a decimal, you are wrong. So where does x go here, a, b, or c? Does it go for c? No. Does it matter then if I put it for a or b? No, it can be either one. So I can do x squared plus 7 squared, or I can do 7 squared plus x squared. It does not matter to me. I'm going to do x squared plus 7 squared equals 9 squared. X squared stays as x squared. 7 squared is 49, and 9 squared is 81. It's important though. Oh, yep. Okay, great question. I know 9 is the hypotenuse because it's across from the right angle. So, and I physically draw an arrow sometimes to go across from it. Also, the hypotenuse is the longer side. So if you're given 2 side lengths, I know 9 is the bigger number. Yep, several ways. I'm going to do 81 minus 49, and I get 32. X squared equals 32. I'm going to square root both sides. Square root, square root. X equals, okay, well, I know the square root of 32 is not a perfect number, so we got to do our factor tree off to the side. We did a lot of factor trees back in chapter 7, but in case we didn't, or in case you forgot something about them, we just do our factors all the way down. So I know 32 is 4 and 8. So I'm going to make 4 be 2 and 2, and I'm going to make 8 be 4 and 2, and I'm going to make 4 go down to 2 and 2. And remember, under a square root, I take out anything that's a match. So anything that is paired up. So I'm going to do this is a pair of 2s, and this is a pair of 2s. And this last 2 doesn't have a friend, so he has to stay under the radical. Outside the radical, I've got 2 times 2, and then I have just 2 by itself underneath the radical, which makes us go to 4 radical 2. You do not have to do that in-between step I did. Some people still are at various levels of understanding this. So if you got it, you can go right to 4 root 2. All right, am I moving too fast, or are we doing okay? Doing good? Awesome. All right, next one, very similar. This one says solve for the variables. This one is like heartbeat or Nike swoosh. What we can do is we can find one of the sides, though, using Pythagorean theorem. I know that I previewed this in one of the lessons, so a lot of you might think, oh, I know I can heartbeat this over this equals this over this. Well, I don't know this length right here. And then I also don't know this length right here to find y. So I'm going to do Pythagorean theorem to find both x and y here. I know I've got a little right angle there. So I've got 6 and x and 10 in this triangle. Which of those is my hypotenuse? Is it 6 or x or 10 is my hypotenuse? 10 across from my right angle. So I'm going to do 6 squared plus x squared equals 10 squared. 6 squared is going to be 36. X squared stays as x squared, and 10 squared is 100. Minus 36 from both sides. I get 64. And then now I get to square root both sides. And I get x equals 8. Here I only want positive numbers because it's the length of a side and you can't have a side be a negative number. All right, cool. X equals 8. So I know that this part right here is 8. How do I find out this part right here? 12 minus 8, which is 4. So we just did 12 minus 8 to get that part. And then now I've got another little triangle over here. Which is another right triangle, and I can find y. Can someone tell me my Pythagorean theorem if I want to find y of the pink triangle? Okay. Awesome. Why is y the hypotenuse? Very good. It's across from the right angle. 16 plus 36 equals y squared. 16 plus 36 is 52. Ooh, is 52 a perfect square? No, we're going to have to do a little work. Square root, square root. Let's see, square root of 52. 2 square root 13. Not square root 13. Yep, yes, sorry. I couldn't think that fast enough. Yes, so Emma made her factor tree. Emma was just moving too fast for me today. 2 and 2, so I get to take a 2 out. 13 stays on the inside, so y equals 2 radical 13. The reason I got confused for 1 second is I was helping kids this morning and we keep putting the wrong thing inside and outside. So remember, it's the thing that doesn't have a friend stays inside. I saw it like on our quizzes, perfect work, and then we got here and we wrote 13 root 2. No, if it has a partner, that comes out. If it doesn't have the partner, it stays inside. So that's why 13, that's why Emma was right when she said 2 root 13. All right, that's it. Questions, concerns, comments? All right, let's keep going. Recall, so from a previous chapter, it says to determine whether a triangle can be formed with 3 segment lengths, you use triangle inequality theorem, which states that A plus B must be bigger than C. I don't remember if we did this online or in person, but like I always try and get like 3 like objects and I hold them up. Do you guys remember when I did that? And I was like, no, they don't fit, or like, yes, they do fit. Maybe reach back in the depths of your memory. Maybe you're like, sure, whatever, Miss White. This is what it would be. A plus B is greater than C. So we have to have 2 of the sides have to be bigger than the third side when you add them together. So we're going to do a couple quick examples. So can a triangle be formed from the given lengths? I've got 5, 11, and 6. I only need to check the 2 smaller ones to see if they add up to be bigger than the third one. So I'm going to do 5 plus 6. Is 5 plus 6 greater than 11? 11, is that greater than 11? Nah. Can I form a triangle? No. Not a triangle.
Why 6B?
I did 6 as B because I wanted to check the 2 smallest sides with the bigger side. You can do 5 and 11 is bigger than 6. You can do 11 and 6 is bigger than 5. But the one that's not going to work is the 2 smaller ones. So I just saved myself some heartache. I'm like, okay, well, if the 2 smallest ones are bigger than the third side, then we're good. Yep. So since this doesn't form a triangle, it's technically nothing. But I think of the third side as like the biggest side. And in a right triangle, that's the hypotenuse. And in a normal triangle, it's just the biggest side. Good question. All right, one more. I've got 13, 5, and 7. So here I'm going to add again the 2 smaller ones to see if they're bigger than the other one. I've got 5 plus 7 is greater than 13. That's 12. Is 12 greater than 13? Nah, not a triangle. Yep, that's all those two are. I'll leave those up for a second. Make sure I said all I wanted to say on the first page. Yep. Yep. Okay. Now we're going to the back side. It says converse of the Pythagorean theorem. So that means, remember we did converse a long time ago. If something, then something. These conditional converses when you switch them. So now we're just switching the Pythagorean theorem around. So this one says we're determining whether a triangle is a right triangle. So the converse states, if the squares of the length of the hypotenuse of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if I think about it in terms of if then, before I said if it's a right triangle, then we can do a squared plus b squared equals c squared. Now I'm going to say if a squared plus b squared equals c squared, then it's a right triangle. So if c squared equals a squared plus b squared, then ABC is a right triangle. If it's not, though, there are two options. Okay, make sure you have this down so far. I'm just checking before I say something. Okay. Everyone good so far? So we're going to say if we see a triangle and I'm like, okay, if c squared is equal to a squared plus b squared, then that is yes, that is a right triangle. However, if that's not true, if they don't equal each other, if c squared is less than a squared plus b squared, then the triangle is acute. And I think it's acute because it's less than. If c squared is less than a squared plus b squared, then it's an acute triangle. If it's the opposite, if c squared is greater than a squared plus b squared, then the triangle is obtuse. Any questions so far? Okay, the next one says explain whether a triangle is a right triangle. So this is what we're going to do. We're going to set c squared equal to a squared plus b squared. Now my question for you is, what's c squared here? Why? It looks like this would be the right angle, right? It's not marked, but if there would be a right angle, it should be here. Another thing we can do is look for the bigger side. So I know 6 is the smallest side, definitely, but I truly don't know between 6 root 5 and 12. So you can always throw in your calculator and be like, okay, what would 6 root 5 be as a decimal? What would that be in comparison to 12? So I'm going to do that really quick. If I do 6 times the square root of 5, I get 13.4. So that's another way to know that that is definitely the biggest side. So we're going to say C is 6 root 5. B and A are interchangeable, but the biggest side is 6 root 5 here. Everyone okay with that? I said that 6 root 5 is the biggest side. Okay. Let's do it then. So we're going to do 6 root 5 squared equals 6 squared plus 12 squared. And I'm kind of like put a question mark because I'm like, is it? We don't know. We don't know. Now you might see 6 root 5 squared and immediately be like, what do I do now? Anyone think that? Maybe yes, maybe no. I want to square, thanks for a minute. I want to square 6 and I want to square root 5. What is 6 squared? What does that equal? 36? The square root of 5 squared. Anyone know what that is? That's just the square root of 5. Yes. Ryan, what are you thinking? So technically that's the same thing as 5 squared and then still under the radical. What's the square root of 25 though? 5. So that's the same thing as 36 times 5. You can think of, this is inverse operations. So square of a square root, those just cancel each other out and you're just left with whatever's underneath the radical. So that's a shortcut. The more we do this, you should just know the square root of 5 squared is 5. And then 36 times 5, 180. Okay. I'm just going to carry this down. 6 squared is 36. 12 squared is 144. So you guys probably like, oh yeah, I got 6 squared and 12 squared, but 6 root 5 squared, are we okay with that now? We get that it's down to 180. And now I'm going to do 36 plus 144, and that equals 180. So is this a right triangle or an acute or obtuse triangle? It's a right triangle. A right triangle. Now, if I say tell if something's a right triangle, show calculations, it means you will not get full credit unless you do all of this right there. Okay. Any questions so far? All right, we got 4 more. We're going to first decide whether they're triangles, whether it can be a triangle. Second, we're going to decide whether it's right, acute, or obtuse. All right, let's look at number A, letter A. I've got 6, 9, and 10. So I'm going to add the 2 smallest sides and see if they're bigger than the biggest side, just to even see if I can do this problem. So I'm going to do 6 plus 9. Is that greater than 10? That equals 15. Is 15 greater than 10? Yep, so that's a triangle. Now we want to do c squared equals a squared plus b squared and kind of see what happens. So I'm going to do 10 squared equals 6 squared plus 9 squared. You guys okay with that? Okay. 10 squared is 100. 6 squared is 36, and 9 squared is 81. Now I'm going to do 36 plus 81. Now, to be honest, you don't even have to do that because we know that that's going to be bigger than 100, right? There's no way I'm going to add 81 and 36 and get something smaller than 100. But if you weren't sure, you can still add it together. It equals 117. 117 is the bigger number, so I'm writing this inequality sign because the bigger one eats the bigger number. I know that's like a second grade skill, but I'm not great with less than or greater than. Anybody else? I kind of suck at it. So I have to think like the bigger one eats the smaller one. So 100 is the smaller one. So it's 100 is less than 117. It's not right because they would have to equal each other if it's right. I'm going to go back to my key up here, and it says if c squared is less than the other number, then it's acute. So 100 in this case is my c squared. 100 is less than 117. So this one is an acute triangle. Acute triangle. Everyone okay with that? Let's do the one underneath it just because we're already on this side. And so if you're still copying, you can use that work already up there. So for letter C, I again need to check and see if it's a triangle first. So 2 plus 2, is that bigger than 5? Oh, no, it's not. 2 plus 2 is not bigger than 5, right? Is 4 bigger than 5? No way. This is not a triangle. So I can't tell you if it's acute, right, or obtuse because it's not even a triangle. Come back, triangle. So now I've given you an example of yes, where it works, and we had to find out whether it was right, acute, or obtuse. Now I gave you an example of it's not even being a triangle. Any questions so far? We got 2 more. If you're really on fire, you're already started on them without me, which is great. 8, 18, and 24. Let's see if that works. 8 plus 18 is greater than 24. That equals 26. Okay, 26 is greater than 24. That's real. Now I got to do 24 squared because that's the biggest one equals 8 squared plus 18 squared. 24 squared is 576. 8 squared is 64. And 18 squared is 324. Am I moving too fast or everybody with me? All right, 324 plus 64 is going to be 388. So I've got 576 equals 388. Okay, well, they're not equal, so it's definitely not a right triangle. And it looks like my first number is the bigger number, so I'm going to write 576 is greater than 388. I'm going to go back up to my little notes and see what happens when c squared is greater than a squared plus b squared, and that means it's obtuse. C squared is greater than a squared plus b squared. Triangle is obtuse. So I'm going to say obtuse triangle. Am I moving too fast or are we doing okay? Got one more. Now this next one, I don't even really know where to start because I don't know what's bigger. So I'm going to see what root 13 in my calculator is. Root 13 is about 3.6. Now we all might be want to put 6 plus 7 is greater than root 13. Well, root 13 is the smaller one. So I have to do 7 is the bigger one. So 7 is my C, and I'm going to do 6 plus root 13, or 3.6. Is that greater than 7? It is going to be, it's going to be 9.6, which is greater than 7. So we're good so far. We good so far? Okay, now I'm going to do 7 squared equals 6 squared plus root 13 squared. You can keep it as 3.6, but you're going to see in a minute why I would rather write it like this. And that reason is the square root of a square, or a square of a square root, just cancels each other out. So that's just going to be 13 by itself over here. So I've got 49 equals 36 plus 13. And I'm going to do 36 plus 13, which is 49. Oh, they equal each other. What does that mean? We got a right triangle. Very good. All right. I think that's notes. I'll go back to this last box, those last two that we did. Anybody have any questions for me? All right. I really appreciate you guys listening to me on the day before spring break. I know that that's a lot to ask, but it means a lot that you guys paid attention. If not, I just recorded the video and I'm going to stop that now.